What we have already seen about triangles are they have A, B, C. Okay, they have three sides. So AB, BC and CA. And generally speaking, the vertices, right? The vertices are named using capital letters, and the sides, the length of the sides are named using lowercase letters. Again, generally speaking, the alphabet used to specify the side of a triangle is the lowercase alphabet corresponding to the opposite angle. Three vertices, three angles. So this is C opposite to this. Now this doesn't matter, whatever triangle it is, the naming is done like that. So opposite to capital B you have lowercase b, opposite to capital A you have lower a. Now the angles can be named using different ways. We can use the angle symbol and the vertex name, right? So angle C. Okay, let's make it a little bit more slanting so that we don't confuse it with L. It can be also named as angle ACB, right? Middle term. Or we can also give it a name, right? So let's say alpha. So we can just say alpha or angle alpha. Apart from this, we have also seen that the sum of the three angles, right? So angle A plus angle B plus angle C is equal to 180 degree, right? That's always the case. Trigonometry is the study of relationship between the angles and the sides, and mostly it is used in heights and distances problems. We will see as we go along how it can be really helpful. Here when we talk of triangles, we are talking of special triangles where one of the angles is 90 degree. Okay, so if I have this triangle, then this has to be, one of the angles has to be 90 degree. This, let's call it as alpha, let's call this as beta. So A, B, C, B, A, C. Why do we talk of heights and distances? At a, right, let's draw an angle. Now here this could be a tree, it could be a mountain, right? It could be a plane flying in the sky. So this side would be something that we want to measure. Now this can also be called as height, altitude. Yes. Similarly, if this is the missing side, then this, as you can see, is the distance. It could be the distance. It can be the width of the river, distance from a building or distance from a object, or the length of the shadow. So it could be distance, width, length. Okay, so to measure heights and distances, we use the topic of trigonometry. So what is trigonometry? Basically, it's a set of trigonometric ratios, study of heights and distances using certain ratios. I'll just mention this. But before I mention that, let's see one very important aspect. Long time back, it was discovered that irrespective of the length, certain ratios are constant for a given angle, right? So let's name this first A, B, C, B1, C1, B2, C2, right? So here, if you notice in any of these triangles, ABC, A, B1, C1, A, B2, C2, we can name these, we can list down the ratios like this. So let's list down the ratios. A, C, let's say BC by AB. It was found that this is the same as B1 C1 by AB1. It's the same as B2 C2 by AB2. Similarly, AC by AB, AC1 by AB1, AC2 by AB2. What you can do is, using a scale, you can draw these triangles, actually measure the lengths and calculate the ratios. You will find that all of them are equal. Or using the concept of similar triangles, you can again prove this. In each of these triangles, BC, B1, C1, B2, C2, we can call them as opposite sides, right? Opposite to what? Opposite to this angle, opposite to alpha. Now AB2, this part, and from A to B1, A to B2. Now this is called a hypotenuse. Okay, hypotenuse. And once we know the terminologies, we don't even have to say side. Opposite by hypotenuse. Now AC2 is called adjacent because it is adjacent to the angle, adjacent by hypotenuse. Okay. Now this particular ratio remains constant for a given angle. If the angle changes, of course, the ratio changes. Now this was given a name, sine of alpha, sine of a particular angle. Later it was shortened to sine of alpha, and then they this of also can be ignored. Sometimes when this alpha is not a simple right term but expression, we also write it as sine alpha within brackets. Similarly, adjacent by hypotenuse is the cosine of the angle, cosine of alpha, or cos of alpha, or cos alpha, or cos alpha, right? So you can use this or this. You should not write OF. Okay, going back to our right angle triangle. Remember, this is, all these triangles have to be right angle triangle. So we have seen sine alpha is equal to, you have to remember this, opposite side by hypotenuse, so B by C. Cos alpha is adjacent side by hypotenuse. Now just let's figure out all the different ways in which we can find the write the ratios. Okay, so we can write, we have seen B by C, A by C. We can write opposite side by adjacent side, not C but A, B by A, right? This is called tan alpha, right? Tan stands for tangent. Similarly, we can have reciprocal of sine, that is C by B. We can have reciprocal of cos, that is C by A, and we can have a reciprocal of tan. Okay, so this is called cotangent, cotan or cot alpha, cotangent. C by B is cosec, alpha, cosecant. C by A is sec or secant. This is sine, this is cosine, tangent, cosecant, secant, cotangent. These are the 6 ratios that we have. Now, naturally, if we talk of a different angle, then the whole thing will change. So, if we say sine beta, now sine beta would be what? Now, in this case, opposite will be A. So, A by C. Cos beta. Cos beta would be what? Now, in this case, adjacent would be B. B by C. Tan beta is equal to, remember, tan is opposite by adjacent. So, opposite is A by B. Cosec beta is equal to what? Hypotenuse by opposite. So, hypotenuse is C. Opposite in this case is A. Sec beta So hypotenuse by adjacent. Adjacent is B. Cot beta is equal to what? B by A. Just to simplify the whole thing, you have to remember only sine of an angle. So sine alpha is equal to opposite by adjacent. Cos alpha is equal to, sorry, not adjacent, I don't know why I keep, okay, hypotenuse. Cos is adjacent by hypotenuse. Now tan alpha is opposite by adjacent. Cosec, sometimes it is also written as CSC. So cosec alpha can be written as 1 by sine. Secant alpha is equal to 1 by cos alpha. Cot alpha is equal to 1 by tan alpha. Okay, these are the various trigonometric ratios. Now, as far as the worksheet is concerned, just write the ratios. Let's do the first one. Sin theta. Sin theta is equal to what? You have to remember. Okay, sin theta is equal to, remember, opposite by hypotenuse. So 17 by 145. Cos theta is equal to adjacent by hypotenuse. So 144 by 145. Tan theta is equal to, remember, tan theta can also be written as sin theta by cos theta. Let's very quickly see. If we divide sin theta by cos theta, what do we get? Opposite by hypotenuse divided by adjacent by hypotenuse. Now let's multiply, convert division into multiplication using the reciprocal. So hypotenuse by adjacent. So here hypotenuse goes. So you are left with opposite by adjacent, which is nothing but tan theta. Opposite by adjacent. So this can be written as 145 into 145 by 144. So 17 by 144. Okay, now for this itself, I'll write the remaining. So sec theta is, remember, 1 by cos. If you remember 1 by cos, then it becomes easier. So it would be 145 by 144. Cosec theta is 1 by sin theta. So this would be what? 145 by 17. Cot theta is reciprocal of tan theta. So 144 by 17. Okay, now if we look at the last side, this is a little bit multi-step kind of problem. Here you are given that opposite is 4, adjacent is 3. See, the moment you see this, you should know it is a right triangle, right? Using Pythagoras theorem. So you can say hypotenuse is equal to square root of 3 square plus 4 square, which is 9 plus 16, which is 25, which is plus or minus, plus 5. Actually, remember, let me just cover one more aspect you should know, right? This is hypotenuse square. Okay, so this would come like this. So hypotenuse square is equal to 25. So hypotenuse is equal to plus or minus square root of 25, right? If you put HYP as 5, 5 square is 25. If you put minus 5 square is also 25. But since we are here talking of lengths, right, it cannot be negative. That is why, even though it is plus or minus, we focus only on the positive numbers. So now we know hypotenuse is 5. So now that we have all the three sides, now we can very easily write opposite by hypotenuse, adjacent by hypotenuse, tan is sine by cos, that is 4 by 3, and so on. So that is trigonometric ratios. So now practice. Bye for now.